So today's question is the bottom of page 17 of the Graphics in Design and Communications. All right, so this is the question we're looking at today. We're going to get our setup in and we're going to go two auxiliaries. We have auxiliary elevation, auxiliary plan. All right, what we want here is we want a true shape of this cut surface, this portion cut off. All right, so what we're working on is our setup and follow on from there. Okay, we're going to start with our plan first. So this shape is a tetrahedron. So a tetrahedron is all sides, so there's four sides to it. All right, all the sides are equal. They're all equilateral triangles basically on all four ends. Okay, so we're going to start with this. We're going to pop in our lines and we'll get set up from there. Okay, right, so let's get that in. So we'll keep it up on the page now as well, all right, because in the solution it's coming down, going back over, so we're going to keep it over to the right and keep it high enough, okay? So give myself enough room, keep it up about here, all right? So I'll put in my XY line, Y line. I'm going to pop in then our tetrahedron, so our equilateral triangle down here. So we will says in the question there in the red box, remember we always read the red box, tells us there it is 75, so we'll step out 10 just to give a bit of space away from the XY line, and it's 75 long. Okay, so we can heavy back portion there, equilateral triangle, so 60 degrees. Alright, we're going to do this nice and light because there's a portion that gets chopped off here as well. Alright, to get the center of this, nice and handy, we're just going to bring a level line because this triangle's on its side. We're going to bring a level line over, we'll split our angle down, and there is our center point found. Again, keeping this light because there's a portion chopped off. Now, we'll transfer all this information up above. Alright, so all sides are equal, and including these, they're all the same length, but they're just in a different view, so we can't see them. Now, going back to what we've learned before, alright, we need to find the full height, the proper height of this, alright? So we need to remember, alright, so this is the edge here, so they have it labeled, actually they haven't labeled it, so we're just going to label it, so A, B, C, and O. Now O is up here somewhere, alright, we don't know exactly where. C is here, A and B is here, alright, and C to O is what we need to find. So we need to remember, at a level line in any view is a true length in the opposite view. So taking this into account here, so this piece of information here, C to O is a level line, so therefore it is a true length in our elevation. So get your compass, set it to one of the sides, O to C, whatever, because they're all the same. But C here, the steel bit here, swing your arc, where it hits, that is the apex of our tetrahedron. Again, nice and light because something's getting chopped off here. Alright, now it tells us that the portion that's getting chopped is 54 off the ground. So we'll measure up 54. Bring that across. Get there. Heavy that in there. they have them numbered 3, 2, and 1. So 3, 3. Now let's get 2 and 1. So it tells us 1 is 25 away. So we'll measure 25 along this line, this level line for number 1. That there is number 1. Alright, so that is number 1 up there. And number 2 is 16 away. 2 and 2. So let's join these up. Alright, so that is our setup for the question, elevation plan done. Alright, so this is the surface, this cut surface here. Here it is in elevation. So those are the two surfaces that, so in our two views. Alright, that's what we're looking for. We need to get the true shape of this cut surface. Alright, so what we need to first do is we need to get an edge view of this surface. If we get an edge view of this surface, we can look perpendicular to that edge view and we can get its true shape. Alright. Excuse me, sorry. So we need to look along a true length to get its edge view. Alright. Again, using this up here, again, it's very important. A level line in any view is a true length in the opposite. So 1 to 2 is a level line, so therefore 1 to 2 is a true length. So if we look along true length, so I can just pop it in here. Look along a true length to get an edge view. So slide and set squares. Right, there is our edge 1 to 2. I'm going to send it down. So we'll send all our points. Nice and light, so just fades into the background. Keep it as close as you can here as well. So we're creating a new XY line. X1, Y1. Okay. So we want to get our heights. So if we need to get a heights for, this is going to be our auxiliary elevation. We're going to step back one XY line. Another important piece of information down here. Going to be used throughout. Step back one XY line and measure up. Okay, so here's our XY line. I'm going to step back this one. I'm going to measure up. Here we give. I'm going to be given it. All right. So A over here is on the ground. It's on the ground there. B is on the ground. So don't even label it because it's already done for us. C we don't need. 2 and 1 both on the ground, and they should be given as a point. If you look along that line, you should be given it as a point view, which is exactly what we want. Now we just need to get O and 3. So compass from the XY line, we measure up. Three. And O. Oh, never brought down O. Apologies. check that height hasn't changed. Oh, so O. Oh, now we can join them up, all right? So O2A. Right, if you're ever wondering which is dotted and which isn't dotted, right? I always do a little pencil trick. So this is me looking. So whatever the pencil touches is heavy. So A is heavy, O is heavy, 3 is heavy, 2 is heavy. 1 is at the back, B is at the back because the pencil never touched it. Okay, so they're at the back. So therefore B has to be dotted. Okay, O3 is heavy. And then 1, 2 to 3 is heavy as well. Okay, so this we're after finding an edge view. Edge view of the surface. All right. Now, last thing we're going to do is we're going to look perpendicular to it. So we want to look okay, we'll look perpendicular to the edge view for its true shape. So back to our set squares again. Here's our edge view. Step back a little bit. Now we'll send it on. Won't forget O this time. Alright. So new XY lines. The last one was an X1, Y1. This is an X2, Y2. Now, getting our heights. So, looking in this way, this is where we're getting our view. We step back one XY line. So, back to this little rule here. Here's our XY. Step back one XY line and we measure out to the view that's there. Or, sorry, apologies, the other way. The view that's there. Alright. So, step back one XY line and measure out. Okay. So label as you go. Don't just put them all in because then you're going to get lost in which is which. B. One. Two. Three. And finally O. Oh. Now, I got these popped in. So, where are we? So we're looking in this way. Now, the only time when we do our pencil trick, it's harder to do that. So, I'm going to pop it in. This is the most extreme out here. Definitely be able to see that. 3, 1. They are going to be at the front because that's where we're looking. This is our true shape here. So we'll put in the stuff we definitely know at the front, which will be the shape. 1 to B, 2 to A, you can definitely see that. A to O. Alright, so what's dotted will actually be B to A, because that's at the back. And what you're left with is our true shape. Okay, that's that question kind of walk through, step through with a few little hints. All right.